So a simple machine is, like it says in its name, it's simple. And what it does is it helps us move something. So it's a device that helps us move something. It says transfer energy into a single motion. And what that means, again, is just moving something. So it makes work easier. We're going to define work later, but it's going to make moving an object easier. That's what a simple machine does, and we're going to go over the 7 moving types.
Alright, so before we do that, we actually have some vocabulary. So first we have force, so if everyone gets your hands out, put them together and push. That's a compression or a pushing force. Now if you flip your hands over and pull, that's a pulling force or tension. Next we have resistance, and that's just the force that you have to overcome to actually move an object. So if I push on this wall, am I ever going to move it? No. No. And does that mean it has a high resistance or a low resistance?
Low resistance.
Exactly, low resistance, right? So it has a high resistance, and something smaller, like this DC converter, has a low resistance because it's really easy. Next we have effort, and that's just the amount of force needed to overcome that resistance. So to move this wall, it would take a lot of effort, whereas moving this windmill takes hardly any effort. And then lastly, we have work, which is a force multiplied by a distance. So it's the amount of force used over a certain distance, and we get that just by a simple multiplication of force times distance.
So if we don't move something, do we do work? No. Okay. And you can get as detailed about that as you want, depending on the class. Again, if they're smart, then go ahead and elaborate and have to maybe calculate something.
This is the follow-up one. This is the lever.
Oh, cool. So a lever actually consists of an effort arm and a resistance arm. So in this diagram, and a fulcrum, by the way. So if we all take our hands out like this is our rigid beam. If it's not rigid, it's not a lever. And then we put our hand under here like this. That's our fulcrum, and we rotate it. What does this look like?
Seesaw.
Cool, or tater tot. So here's our effort arm, and here's our resistance arm. So there's all different classes of levers, and the differentiation of the classes comes from when the effort arm and the resistance arm, basically the effort, the resistance, and the fulcrum are going to change in relation to each other, and that's what defines a certain class of a lever. But as you can see here, we put our effort in here. It's going to lift something up, and it's going to make lifting something easier.
Okay, so as Cameron said, we have 3 different classes of lever. The very first class of lever is the fulcrum, is actually in the center of the rigid beam, so somewhere in the middle. And the resistance arm and the effort arm are on either side. So that lever we just saw is an example of that. Also, we have a tater tot or a trebuchet. So either one of those are good examples of a first class lever.
Second class lever is when the fulcrum is at the end of the beam. And the effort and the fulcrum are on opposite ends of the beam, and the resistance is in the middle. So for this, I haven't presented this in a while. You have to picture sort of like a board. You put a board on the end of the table, like this. Okay, and I put something here and I lift it. That's the second class lever. Just for those of you who are more visual. Examples of second class lever. Is it foot? Remember we went over this, man. I didn't go over this. But another good one is a wheelbarrow.
Just so you guys know, it helps if you have like a whiteboard. If you just, as you're going through, if you just draw them on the board, just like really simple diagrams.
Yeah.
Yeah, it helps.
So this one, this is the fulcrum. F is for fulcrum. The R is for resistance, and then the AF is applied force. So the effort. Okay. All right. So third class of lever is the fulcrum at the end of the beam. The resistance is on the opposite end of that fulcrum, and then the effort force is actually in the center. So basically, this comes down to anything you can swing. So an axe, baseball bat, hockey stick, golf club, anything that you have to swing is a third class lever.
Murder items. So next we have a wheel and axle. So this is the only simple machine that consists of 2 parts. Okay, so it's got a wheel and an axle, and what makes this different than a wheel or a pulley is that these are actually connected. So if we look here, what a wheel and axle does for us is it gives us what's called a mechanical advantage. So if you look at these weights, W is larger than P, so that's because it's on a wheel. And anything with a handle that you can turn is a wheel and axle, including the door. So screwdriver, here's the wheel, here's the axle, door handle, wheel and axle. Again, if you drive a Ferrari, you have a wheel and axle in your car. It's good. And something you can say here too is like a school bus has a bigger steering wheel, okay? Because it's harder to turn the bus. So you get a bigger wheel, it makes it a little bit easier. Yay, bam.
That was fast.
Was that the leverage one or was that the?
That's the levers, wheel and axle.